Let's solve the reverse kind of problems wherein the phase and magnitudal plot is given and we are supposed to find what is our x of t signal. So let's consider this signal wherein the problem goes like this: determine the time domain signal corresponding to the magnitude and phase spectra shown in figure with omega naught is equal to pi, and the magnitude spectra is this one and phasal spectra is this. So whenever these kind of problems are there, we have to note down what is given here first. So we can see that at -4 the signal is there having its magnitude and phase, similarly at -3 and even at +3 and 4. So let's write this signal as, we can write that x of 3 at 3, x of 3, it is the frequency domain representation, so capital x of 3, so its amplitude is 1 and e raised to the phase is minus j pi by 4. Similarly at 4, x of 4, its magnitude is 2 e raised to plus j pi by 8, and at -3 its magnitude is 1 and phase is pi by 4, and at -4 its amplitude is 2 and phase is minus pi by 8. So we'll write this whatever is given, and then we have to use the formula which is suitable to this one, and the formula which will be suitable is this one. As the formula we know, this is our x of t is equal to, we have that formula of the Fourier series. So by the synthesis equation we can write x of t is equal to x of k e raised to j k omega naught. So we have solved the problem by last problems by using this. So e raised to j k omega naught t it is, and the value of omega naught given is pi. So let's substitute that in and we'll write, and we know that only at this +3 4 and -3 -4 it is available. So this k for the formula is from -infinity to +infinity, but when we do the expansion we know that it is existing from -3 to +4. So let's write that one. The values available are, let's write this one as x of, now for this formula k is taking -3 -4 +3 and +4. So let's substitute those values. So we can write x of t is equal to, let's write, so we can take the leftmost value, so it is -4, or we can take any values. Let's go with this +3. So we can write x of 3 and x of 3 e raised to, it has to be, if it is 3, e raised to j, it is supposed to be e raised to j, k is 3, so e raised to j 3 omega naught, as omega naught is pi, so the value of omega naught for this problem is pi. So let's write this, pi t. E raised to x of 3 e raised to j 3 pi t. The values become x of 4 e raised to j 4 pi t, x of -3, because at only these places it is existing, x of -3 e raised to j -3 pi t, and x of -4 j -4 pi t. Now let's substitute the values of this x of 3, x of 4 from this. When we substitute, we get x of 3's value is 1 into e raised to -j pi by 4. So its value will be 1, no need to write that, e raised to j minus e raised to minus j pi by 4. That is with minus sign. Then similarly it is the same thing, e raised to j 3 pi t. You can write. And we can notice that with this e raised to minus j3, when we substitute this values, x of minus 3 is e raised to j pi by 4. So let's write this term here. Otherwise we can write, so let's substitute and then we'll recombine. So it would be x of 4 is 2 into e raised to j pi by 8 . So x of 4 we have written, x of 4 is 2 e raised to j pi by 8 and e raised to j4 pi t as it is. X of minus 3 is this one. By writing these equations, we get to know that this e raised to j3 pi t and e raised to minus j3 pi t, and these two signals or these two terms are identical and these two are identical. So we'll rearrange those. We can write this first term as e raised to j 3 pi t, and as j is outside, minus pi by 4. And similarly we'll write this term as with a plus sign. It is e raised to minus j, e raised to minus j, minus we are taking outside, so e raised to minus j 3 pi t into the bracket, and let's write this one as either minus. So we write this one e raised to minus j 3 pi t and minus of pi by 4, which makes it as plus pi by 4 after solving. And similarly we'll write this term as it is plus 2 is common in both of those. So let's write 2, and within the bracket it is e raised to j pi by e raised to j 4 pi t plus as this 2 is outside, so e raised to, it would be, let's write minus, let's take minus outside, so into the bracket 4 pi t and it would be plus pi by 8. Let's complete the brackets and this bracket also. Now we have to get it to the trigonometric form. So to write them as the sine and cos forms, so we have to divide and multiply by 2. Let's put the bracket, divide and multiply by 2 here, and the same thing, this all will be divided by 2 and even multiplied by 2. So this becomes is equal to, so this x of t is equal to cos of e raised to 3 pi t minus pi by 4, and it is minus 3 pi t minus pi by 4. So it can be written as 2 times cos of 3 pi t minus pi by 4, and this term would be, the second one is, it is 4 times, again it is cos of 4 pi t plus pi by 4. So that is its expansion. So when even, it's pi by 8. So this is our time domain signal, and if we go in a reverse fashion with the known process as we have learned, by expanding this will even we arrive at the magnitude and phase spectra as this one can check it. Now let's solve this problem, wherein for the signal x of t as given in the figure, it is a continuous time periodic signal. We have to find what is its magnitude and phasal spectra. So let's observe the signal and try to find out the required components. Now by looking at the signal, we can understand that the value of the signal is going like the x of t value. X of t is equal to e to the power minus 2, and the period, will find the fundamental period of the signal, and the cycles are repeating after one time duration. So 0 to 1 it may be, or from 1 to 2, but the t of the signal is 1. And for these kind of problems we have to use a formula wherein x of t will be involved. So the formula is the second formula we need to use, because x of t is given and we have to substitute it. So the formula will be, now x of k finding, x of k is equal to, we need to write the formula as we are familiar with, it is 1 by t integral over the duration t for one time period, it may be anything, x of t, it is e raised to minus, remember as the time domain signal comes, minus sign will be there, e raised to minus j k omega naught t it is. Now t dt, what all we have, we need to substitute over here, we need the value of x of t. The x of t here is e raised to minus 2, so that is there with us. Then we need is what is its period t, we need what is its fundamental period. So fundamental period t, by looking at the signal, is it is 1, so let's write 1, so it may be 1 second or what, just it is 1 as per the information of that signal. Now once we know that it is 1, then what is its fundamental frequency? The fundamental frequency of the signal omega naught is equal to 2 pi by t. We'll write it. So when we substitute this way, so we get it is 2 pi. That's it. Now we go for writing in this. So it is 1 by t, which becomes 1 by 1. Means there is no meaning in writing 1 by 1. Let's write at the first step integration. Now let's do the integration from 0 to 1, which is more convenient. So we'll consider this cycle. So over the duration, one cycle, t from 0 to 1, x of t is e raised to minus t, and e raised to minus j, we can write in this fashion, omega naught is 2 pi. Now this integration becomes, it is integration from 0 to 1, and this can be written as e raised to, no need to write 2 times, e raised to, so we can write this as e raised to minus 1 plus j 2 pi k, and t is outside. And let's do the integration of this. We know how to do the integration of e raised to, let's say e raised to some value into t, it is e raised to minus, it is same thing, 1 plus j 2 pi t, 2 pi k it would be, divided by this 3, divided by minus 1 plus 2 pi k. T is from, now T has to be from 0 to 1. When we substitute this, the x of k is given by, when t is 1, it is e to the power minus 1 plus 2 pi k, it is, t is 1, divided by the same value minus e to the power, when t is 0, this all becomes e to the power 0, divided by, it is minus of 1 plus 2 pi k. And to remove this minus sign, we can write this one as e raised to 0 is 1, so it is 1 minus e to the power minus, so we can write this one as e to the power 0 is 1 and this e to the power minus 1, and we can try, let's split this one, e raised to minus j 2 pi k. Now here we know that this one e raised to j 2 pi k, if I expand e raised to j, it may be a plus or minus e raised to j 2 pi k, its expansion is e raised to minus j, or it may be e raised to plus j. If it is expanded, it will be cos of 2 pi k minus or plus j sine of 2 pi k as per this sign. And k is the Fourier domain coefficient or Fourier domain term, and this k can take only the integer values. K can be 1, 2, 3 like this up till in between minus infinity to plus infinity, but it can take only integer values. If k is equal to 1, this equation becomes cos of 2 pi minus j sine of 2 pi, and the value of this one would be 1. If k is equal to 2 also, it is cos of 4 pi minus sine of 4 pi, and always the sign is going to be 0 and this is going to be 1, so the value of this term is going to be, 1. So let's write this term as equal to 1. So when we do that, this term becomes, this total equation is x of k is equal to, this equation is for x of k, and this x of k is equal to 1 minus e to the power minus 1 divided by 1 plus 2 pi k, and the value of e to the power minus 1 we can find out and subtract it from 1. So when we do that, so 1 minus e to the power minus 1 is 0.632. We'll write that value, 0.6321 something we are giving. We'll write this divided by 1 plus 2 pi. Now x of k is this one. The next thing is we need to draw the magnitudal and phasal plots. So in order to do that, we need to go for substituting the different values of this k. So like k is equal to 0, 1, 2, even minus 1, 2 like that, and we'll be finding the magnitude, and by finding the phase also we'll get the phasal plot. So let's do that. When k is equal to, let's find the magnitudal plot, x of k. When k is equal to 0, let's write. So if I put k as a 0, this equation becomes 0.632. 1 plus this 0, magnitude of this 0.632 is that, and magnitude of this also, or let's write magnitude equation. This equation becomes, when k is a 0, this equation, let's write the magnitudal equation, 0.632, and as there is a constant, no need to write its root and even square. 1 plus 4 pi k square. So this can be written as, the magnitude of this one is 1 plus magnitude of this one 2 pi k the whole square. So which will be 4 pi square k square. When k is a 0 here, so this term goes 0, so it will be 0.632 itself. When k is 1, this becomes 0.632 divided by root of 1 plus 4 pi square. K is 1, so 4 pi square. So we need to find what is its value. Similarly, when k is equal to, and remember that for k is equal to minus 1 also, for k is equal to plus 1, even for k as minus 1, the value taken by the magnitudal plot would be same, so no need to calculate it for negative values. So for k is equal to 2, its value would be 0.632 divided by root of 1 plus 4 pi square as it is, but the k is 2. As k is 2, 2 square would be 4. So multiplied by 4, it would be 16 pi square. Works out approximately 0.1. This is 0.63. This would be around 0.13, and this is 0.05, like this. So this is the way how can we find. Even we can substitute k as 3, and we can go for finding what will be its value. The magnitudal plot looks in this fashion. Now magnitude of x of k from the book I am showing you. So it is 0.63, 0.1, 0.05. If k is equal to 3 is taken, it works out to be 0.03. In that way we can take 4 to 3 values, that's enough. Then next point is finding the phasal plot. The phase of x of k. Phasal value of x of k is given in this way. Phasal value of x of k is equal to, now of this itself we need to go for finding. Now we know that if we write, it is plus j0. So let's do it with a different color. It is just a real term, j is a 0. So the angle contributed by this one is 0. So numerator is not contributing anything. So denominators we need to check. And denominator is given by 1 plus 4 pi k. So this j has been forgotten to write. It is 1 plus j is there. This j term is there. And this numerator is not contributing, but what about this denominator? Certainly it does. So for the denominator, let's look that it is x plus jy. Then the angle is calculated by tan inverse for the denominator. As it is for the denominator, let's write 0 minus, because numerator is not contributing anything. So 0 minus tan inverse of y by x. Y is this. It is 2 pi k divided by 1. So no need to write that 1. So it is 0 minus tan inverse of 2 pi k, or we can write this one as just minus of tan inverse of tan inverse of 2 pi k. And in this we need to go on substituting the different values of k. So when k is equal to 0, k is equal to 1, what all the values it takes we need to see. So if k is equal to 0, the value taken by our phasal plot is equal to let's write it with a different color. The values taken would be, let's say for k is equal to 0, so it would be minus tan inverse of 0. So tan inverse of 0 is nothing but 0. So magnitudal plot takes 0 value at 0th instant. Sorry, the phasal plot. For k is equal to 1, what value it takes? Minus tan inverse of, it is equal to minus tan inverse of 2 pi. That's it. Is tan inverse of 2 pi. We need to take it in radians. So minus tan inverse of 2 pi works out to be, so when we do the calculation in radians, it gives minus 1.41. When k is equal to plus 2, it gives the value minus tan inverse of, it would be, k is 2 means it becomes 4 pi. So the value of this one in radians, when it is calculated, it gives minus 1.49. It goes on in this way. So for positive values, when we go for calculation, when we go for k is equal to like minus 1 and all, when k is minus 1, so this term, we remember that we are substituting the minus values. So this becomes Rx of k would be is equal to minus tan inverse of 2 pi minus 1. So minus 1 will make it as minus 2 pi. So tan of minus theta is minus theta, which will make this one as, that's right, it is tan inverse of just 2 pi. And it will take the same values, but with the other sign. So its value would be, it takes tan inverse of 2 pi would be 1.41 only, but it is positive. Similarly, for k is equal to minus 2, it would be plus 1.49. So the magnitude and phasal plots, let's see, the magnitudal plot is this one, the phasal plot is this one. So for k is equal to 0, the signal is taking 0 value. For k is equal to 1, it is minus 1.41, and it is plus 1.41 for k as minus 1, and for k is 2, it is 1.49. For k is minus 2, it is plus 1.49. So this goes on. We need to calculate few more values, just up to 3 also one can run and conclude the magnitudal and phasal plots. And from this it's quite visible that the magnitudal plot is always symmetrical, it is an even signal, but the phasal plot is an odd kind of a signal. The next problem after this one is this one. It is also an important, these all are the exam problems. Find Fourier series coefficients for the signal x of t, which is given here. Now just to see the signal and about this signal, what all is given to us. It is of course a continuous periodic signal. One has to find the Fourier series representation of this one. Then what all is available? The value of the signal is given. It is sine of pi t. Okay. X of t is available. So the equation would be again this one. X of t value is, here it was e raised to minus t. There it is. In the last problem it was minus t. Now it is sine of pi t. Then we need to know what is the fundamental time period of the signal. The fundamental time period of the signal is, just see, 0 to 1. But the next signal is immediately not starting. Now here it was immediately starting. It was the end. Again the same cycle was starting. But here it is not. So there is a 0 value. Again the cycle repeats. Means this is again sine pi t. So the value fundamental time period is t. So omega naught is equal to 2 pi by t, which is 2 pi by 2, which makes it as pi. Then we can go for solving this one. X of k is 1 by t. Integral over the time, the equation is written. Just we substitute the values. T is 2 sine of pi t e raised to minus j k pi t. Omega naught is pi. We have substituted dt. Just we need to do the integration of this. And before that, it has been expanded. We know the expansion of sine is this. And we'll integrate this one from 0 to 1. We have taken this outside. So this becomes e raised to j 1 minus. So by combining this one with each of these terms, two terms are being obtained and they all have to be integrated, and 0 to 1 will be the limit of integration as our signal. Actually 0 to 2 has to be the thing, but we know that from 1 to 2 it is a 0. So we have written it from 0 to 1. And when we substitute, we are getting such kind of a signal, and the signal is a bit complex. We are not going for like drawing the signal, and sometimes it is not being done. So we can have different types of such problems. So even in video resources, this problem is there. The above problem also, this one is solved but not completely. But we know the solution. I think this was there, it is there in the model question papers also. And solve it completely, not only up till this. The next problem dealt is this one. It is x of t is a squarish kind of a wave from 0 to some magnitude. So its value is 1. We can see it is a periodic signal, course continuous. What is the fundamental time period of this? The fundamental time period of the signal is now 0 to 2. So t is 2 for it. Omega naught is pi, same. Then use this equation and go for solving. So for this 1 will be there, and in between 1 to 2 it would be 0. So limits would be from 0 to 1. Limits have to be from 0 to 1. It is 1. So this has to become 1, and solve this one and simplify and try to get the magnitudal and phasal plots. Similarly, this signal, wherein the signal is given by, I think, t. It is a ramp signal. It is t. So t into, even for this, try to solve and get the magnitude and phasal spectra. As this link is given in the WhatsApp group, so I want these kind of problems. There are infinite number of problems of this type. So try to solve these problems. Now here the basic thing is being dealt and few problems are solved. So try to solve different types of these problems, so which will be just a trigonometric things, and integration one has to go for. And this one is also being done but not completely. So I hope the Fourier series will be this one, and if any problem is there, we'll discuss. This problem is solved in Uday Kumar book. Just check the solution of this one.